Welcome to the Securing and Scaling the Data Pipeline module. This introduction section describes the content of this module. This module prepares you to do the following. Highlight how cloud security best practices apply to analytics and machine learning, or ML, data pipelines. List AWS services that play key roles in securing a data pipeline. Cite factors that drive performance and scaling decisions across each layer of a data pipeline. Describe how infrastructure as code, commonly referred to as IAC, supports the security and scalability of a data pipeline infrastructure. Identify the function of common AWS CloudFormation template sections. The objectives of this module are presented across multiple sections, each with its own video. The module wraps up with a sample exam question. This section reviews cloud security concepts that are highlighted in the AWS Well-Architected Framework. The AWS Academy Cloud Foundations course introduced the AWS Well-Architected Framework. The framework is available on the AWS website, and you can find the link on the Content Resources page in your online course. You might find it helpful to open the website now to look at the way that the pillars are organized. This module focuses on using the best practices from the security pillar to secure your data analytics and ML workloads by using the corresponding AWS well-architected lenses. Security and compliance are shared responsibilities between AWS and customers. AWS secures the hardware, software, facilities, and networks that run all AWS products and services. You are responsible for what you implement by using AWS products and services and the applications that you connect to AWS. The security steps that you must take will depend on the services that you use and the complexity of your system. In the cloud, you can apply a number of principles to help you strengthen your data security. Let's take a look at some of those principles. First, implement a strong identity foundation. Implement the principle of least privilege. Enforce separation of duties. Centralize identity management. And aim to eliminate reliance on long-term, static credentials. Next, enable traceability. Monitor, alert, and audit actions and changes to your environment in real time. Integrate log and metrics collection with systems to automatically investigate and take action. Next, apply security at all layers. Apply a defense in-depth approach with multiple security controls and apply it to all layers of your infrastructure. Next, automate security best practices. Automated software-based security mechanisms can improve your ability to securely scale more rapidly and cost-effectively. Create secure architectures, which includes implementing controls that are defined and managed as code in version-controlled templates. Protect data in transit and at rest. Classify your data into sensitivity levels and use mechanisms such as encryption, tokenization, and access control where appropriate. Next, keep people away from data. Use mechanisms and tools to reduce or eliminate the need for direct access or manual processing of data. This reduces the risk of mishandling or modification and human error when handling sensitive data. And finally, prepare for security events. Prepare for an incident by having incident management and investigation policies and processes that align to your organizational requirements. Run incident response simulations and use tools with automation to increase your speed for detection, investigation, and recovery. The security of your data pipeline relies on your control of who and what can access your services and resources, and determining what they are able to do with that access. These control measures are commonly referred to as authentication and authorization, and both of these measures are guided by the principle of least privilege. Identity and Access Management, or IAM, is a web service that helps you to securely control access to AWS resources. Use IAM to control who is authenticated and authorized to use these resources. IAM is integrated into most AWS services, and you can implement IAM to effectively control access to the services that make up your data analytics or ML pipeline. You can define access controls from one place in the AWS Management Console, and they will take effect throughout your AWS environment. IAM also supports multi-factor authentication, or MFA. If MFA is activated and an IAM user attempts to log in, then the user is prompted for an authentication code. The authentication code is delivered to a specifically configured AWS MFA hardware device or to a software-based device, such as Google's Authenticator application. When used in conjunction with AWS CloudTrail, IAM can also support information assurance by providing log records that include the identity information of users that request resources in your account. The term data at rest describes any data that you persist in non-volatile storage for any duration in your workload. The term typically refers to data that is currently being stored and not accessed. Data in transit describes data that is being sent from one system or service to another. Protect both forms of data in accordance with their assigned sensitivity levels by using protective mechanisms such as encryption and access control. You can enforce encryption of data at rest in AWS by setting default encryption in services such as Amazon S3 and Amazon EC2. To protect data in transit, enforce encryption in transit. AWS services provide HTTPS endpoints that use TLS for communication to provide encryption in transit when communicating with the AWS API. AWS Key Management Service, or AWS KMS, is a managed service that provides the ability to centrally manage and securely store the keys that are used to encrypt your data. You can create data keys with unique aliases and descriptions for better management. Automatically rotate your keys on a scheduled basis, and disable or delete keys so that no one can use them. You can also import your own keys instead of using AWS-generated keys. You can use the keys within your applications and supported AWS cloud services to protect your data, and the keys never leave AWS KMS, reducing the risk of your data key being compromised. Logging is the collection and recording of activity and event data. The type of information logged will vary based on the service that conducts the logging, but some elements are commonly logged, such as the date and time of an event, the originating location of request, and the identity of resources accessed. Monitoring is the practice of continuously verifying the security and performances of your resources and data. One AWS service that you can use to monitor your AWS resources is Amazon CloudWatch, which will be covered in this module. The CloudTrail service helps you enable governance and compliance, as well as operational and risk auditing of your AWS account. Actions taken by a user, role, or AWS service are recorded as events in CloudTrail. These events can be used to audit and troubleshoot issues that might arise within your data pipeline and can alert you to possible inconsistencies and unauthorized access or actions. CloudWatch is a monitoring and observability service built for DevOps engineers, developers, site reliability engineers, IT managers, and product owners. CloudWatch collects monitoring and operational data as logs, metrics, and events. You can use CloudWatch to detect anomalous behavior, set alarms, visualize logs and metrics side by side, take automated actions, troubleshoot issues, and discover insights to keep your applications running smoothly. Here are a few key points to summarize this section. Access management consists of authentication and authorization. Adhere to the principle of least privilege with both. IAM integrates with most AWS services and helps you securely share and control individual and group access to your AWS resources. A key aspect of a data security plan is to secure data at rest and data in transit. Logging and monitoring can assist your organization to maintain compliance with local laws and regulations. This section introduces best practices related to the security of analytics workloads. The first group of best practices falls under the category of classify and protect data. This category contains 6 best practices that focus on classifying and protecting data in analytics workloads. To properly classify data, you first need to understand the data classifications and the affiliated protection policies of your organization. Once you have determined the possible classifications, allow the data owners to classify the data and define the access rules based on the sensitivity and criticality of the data. Next, identify security zone models to isolate data based on classification by designing security zone models, beginning at the AWS account level and extending down to the AWS resource level. Finally, identify sensitive information and define your protection policies. Identify the owners of the source data to confirm the classification of their data. As data moves through the analytics workflow, these classifications will ensure that the data is appropriately protected from unauthorized access by personnel or systems. The data catalog is only useful if it's up to date. An up-to-date data catalog will provide an accurate and reliable record of data locations and classifications, which allows for more effective protection of potentially sensitive data. Encrypt workload data in accordance with the policies that govern the classification level. Implement encryption policies for both data at rest and data in transit. You can find AWS service-specific implementation guides on the AWS documentation website. While your organization might have a standard data retention policy, you should also implement classification-based retention policies. Create your backup requirements and policies based on data classifications. You can also create data retention requirement policies based on the data classifications and tailor your policies to individual assets based on retention requirements, taking care to avoid blanket retention policies. Remember that other data-consuming systems will access the data that your analytics workload shares. Because of this, you should require those downstream systems to implement the appropriate data classification policies. Have a centralized, shareable catalog with cross-account access to ensure that data owners manage permissions for downstream systems. Periodically verify that any downstream systems are eligible to process data at the appropriate level of classification. The next group of best practices is categorized under the title of Control the Data Access. In general, an analytics workload will consolidate multiple data sets into a central location. It's important to identify which person or group owns which data set in order to coordinate data access permissions and ensure those permissions adhere to the principle of least privilege. To federate with IAM by using AWS IAM Identity Center, the successor to AWS Single Sign-On, or another identity provider, a best practice is to centralize your workforce identities. As much as possible, limit access to data stores that contain sensitive data using control mechanisms such as role-based access control, or RBAC. Another best practice is to implement dataset-level access controls by building analytics workloads to have the dataset owners control the data access per dataset level. Finally, implement column-level data access controls and enforce the masking of sensitive data through the use of column-level restrictions. This practice will help ensure that end users of analytics applications are not inadvertently exposed to sensitive data. Though unlikely, automated processes and pipelines can experience occasional issues. You can remediate such issues more efficiently by expediting access through the use of emergency access. Ensure that risk analysis is done on your analytics workload by identifying emergency situations and a procedure to allow such emergency access. As you identify risks, prioritize each event based on likelihood and overall business impact level. The final group of data analytics best practices are categorized as control the access to workload infrastructure. Through the use of services such as IAM, you can ensure that your environment is accessible while adhering to the principle of least privilege. Prevent unintended or unauthorized access to your infrastructure by granting the least privilege possible. IAM provides AWS Identity and Access Management Access Analyzer tool for all AWS accounts that are centrally managed through AWS organizations. IAM Access Analyzer aids you in setting and verifying permissions and assists you in refining those permissions by removing unused access. Identify your source and downstream users and systems, and then identify the minimum privileges that each would require and implement only those permissions necessary. You can further secure access by implementing the two-person rule, which can help you prevent unauthorized access, altering, or even deletion of critical or classified information by requiring the presence of two separate users to perform tasks that you deem critical. Monitor infrastructure changes closely. Practices such as implementing a change control board or change advisory board can be helpful to prevent potentially disruptive or harmful changes. A number of AWS services are available to assist you in monitoring and logging those changes. While services such as AWS Config and CloudTrail can provide you with a wealth of audit logs, these records are useless unless they are also securely handled and maintained. Use fault-tolerant storage for your logs and restrict access to the logs to privileged users. Let's look at how to apply some of the security best practices from the AWS well-architected data analytics lens to a typical stream processing pipeline. To classify and protect data, you can begin by understanding your data classifications and your protection policies before the data is processed in your pipeline. This best practice will govern how you handle all of the data that flows through your data pipeline. Next, identify who the owners of your datasets are and request that they properly classify their datasets if they haven't already done so. As data is ingested into your pipeline, record data classifications into the data catalog and keep your data catalog up to date so that you have accurate and reliable records of data locations and classifications. After you identify the source data that you will work with and have established the classification level of each dataset, you will need to implement the applicable encryption policies. For data at rest, use one of the multiple encryption options available in Amazon S3. Secure your Amazon Kinesis data streams with server-side encryption by using AWS KMS. Additionally, you can use classification-based retention policies for your datasets. Back up and retain analytics datasets based on your organization's policies for classified data. Finally, ensure that downstream services, storage services like Amazon Redshift, and downstream workloads honor your data classifications. If confidential source data enters your pipeline, handle the output of your pipeline as confidential data. To control data access, allow owners of the operational data shown in the diagram to determine which people or systems can access data in analytics and downstream workloads. Implement IAM to control which users, roles, or services can access your resources. Every service shown in the diagram integrates with IAM and should be correctly configured to do so. The operational data in this diagram is classified as sensitive, which means that appropriate control measures must be put into place to adequately secure the data. Finally, each service and resource in the pipeline should have emergency access controls implemented to expedite access to your workload in the event of an issue with your pipeline. Controlling access to the pipeline infrastructure can be done in a number of ways. Implement IAM to control user, role, and system access to the data and services within your workload, and isolate your network as much as possible. After you have identified your source and downstream users and systems, identify the minimum privileges that each would require and implement only those necessary. Once you have secured access to your operational analytics pipeline, it's vital that you monitor it for infrastructure changes and malicious activity. Finally, secure the audit logs for all of the services in your operational analytics pipeline and the services that support it. Ensure that you maintain adequate log security over a fault-tolerant storage solution, such as Amazon S3. Here are a few key points to summarize this section. Honor the data classifications and protection policies that the owners of the source data assigned. Secure access to the data in the analytics workload. Share data downstream in compliance with the source system's classification policies. Ensure the environment is accessible with the least permissions necessary. Automate auditing of environment changes and alert in case of abnormal environment access. Pre-processed data and engineer the features are grouped together as the process data phase. The deployment phase begins by identifying your business goal. ML libraries and packages handle all of the data processing, model development, training, and hosting. You will need to review the privacy and license agreements for all of the software and ML libraries that your ML lifecycle depends on to ensure that they comply with your organization's legal, privacy, and security terms and conditions. Review these items regularly and establish a process to do so. You can control much of the software through the use of private repositories or repos. In framing the ML problem, apply the principle of least privilege throughout the ML lifecycle. Also, provide your project with dedicated network environments that have dedicated resources and services. This will assist you to achieve least privilege access to data, assets, and services. Restrict access to data based on individual roles by identifying which roles will need data access and mapping these roles to access patterns through role-based authentication. During the process data phase, you will want to ensure you are protecting sensitive training data against unintended disclosure by identifying and classifying the sensitive data. Handle the sensitive data by using strategies such as removing, masking, tokenizing, and principal component analysis. Document best governance practices for future reuse and reference. Monitor and track data origins and transformations over time. Strictly control who can access the data and what they can do with it. Perform preventative controls, auditing, and monitoring to demonstrate how data has been controlled during its lifetime. Implement integrity checks against training data to detect any unexpected deviances caused by loss, corruption, or manipulation. Data lineage enables visibility and helps you trace data processing errors back to the root cause. Preserve data across computing environments, storing only the data that has business need in order to reduce data exposure risks. Implement mechanisms to enforce a lifecycle management process across the data and decide when to remove data automatically based on age. There are a number of best practices to apply during the train, tune, and evaluate phase. Protect your ML operations environments by using managed services with best practices, including detective and preventative guardrails, monitoring, security, and incident management. Explore data in a managed and secure notebook environment. Centrally manage the configuration of Jupyter environments and enable self-service provisioning for the users. For frameworks such as TensorFlow, it's common to share information such as coefficients as part of the internode cluster communications. The algorithms require that exchanged information stay synchronized across nodes. Secure this information through encryption in transit. Protect against data injection and data manipulation that pollutes your training dataset. Data injections can add corrupt training data that will result in incorrect models and outputs. Data manipulations change existing data such as labels, which can result in inaccurate and weak predictive models. Identify and address corrupt data and inaccurate models by using security methods and anomaly detection algorithms. During deployment, add protection inside and outside of the deployed code to detect malicious inputs that might result in incorrect predictions. You can automatically detect unauthorized changes by examining the inputs in detail and repairing and validating the inputs before they are added back to the pool. Evaluate your use case and determine any bad predictions or classifications. Evaluate the robustness of the algorithm against increasingly perturbed inputs to understand susceptibility to manipulated inputs, and select diverse features to improve the algorithm's ability to handle outliers. Consider pairing models in groups for increased diversity in decisions, and consider using ensembles to build in robustness around decision points. Similar repeated inputs to the model could indicate possible threats to the decision boundaries. An example of this is model brute forcing, where threats iterate only a limited set of variables to determine what influences decision points and derive feature importance. If retraining on untrusted or invalidated inputs, make sure that any model skew is traced back to the data and pruned before retraining a replacement model. Host the model so that a consumer of the model can perform inference against it securely. Enable consumers using the API to define the relationship, restrict access to the base model, and provide monitoring of the model interactions. During the monitor phase, ensure that data access logging is enabled. Audit for anomalous data access events, such as access events from abnormal locations or activity exceeding the baseline for that entity. Use services and tools that support anomalous activity alerting and combine their use with data classification to assess risk. Evaluate services that can be used to aid in monitoring data access events. Verify that you have data access logging for all human create, read, update, and delete, or CRUD, operations, including the details of who accessed what elements, what action they took, and at what time. Here are a few key points to summarize this section. Apply the principle of least privilege throughout the ML lifecycle. Encrypt data in transit to and at rest in the compute and storage infrastructure. To reduce data exposure risks, only store the data that has business need. To detect malicious inputs that might result in incorrect predictions, add protection inside and outside of the deployed code. Ensure that data access logging is enabled, and audit for anomalous data access events. This section introduces concepts related to creating scalable components. Let's look at the stream processing pipeline example from earlier in this module and focus on the services used in the example. In this example, automatic scaling can be configured for Amazon Kinesis data streams by using CloudWatch and Lambda, as you will see on the next slide. Kinesis Data Streams offers an on-demand mode, which you can use to automatically scale your Kinesis data streams without needing to manage provisioning or capacity for your streaming data. Kinesis Data Streams on-demand mode will automatically scale your capacity in response to data traffic. This capability doesn't require you to write new APIs to write or read data and can be helpful when your workload is variable or unknown. If your stream processing needs to be scaled in conjunction with your stream storage, you can configure the parallel implementation of tasks and the allocation of resources for Kinesis data analytics to achieve that scaling. After you have configured the parallel execution for your Kinesis data analytics application tasks, Kinesis data analytics will automatically scale your application's parallelism to accommodate the data throughput. Automatic scaling is enabled by default, and you can disable or enable this behavior. The next slide provides a deeper dive into how you can scale Kinesis data streams by using Lambda and CloudWatch. This slide shows a solution to automatically scale one or more Amazon Kinesis data streams by using a lightweight serverless architecture. The solution uses CloudWatch, Amazon Simple Notification Service, or Amazon SNS, and Lambda. The streams are processed by using a single SNS topic and Lambda function. Each stream requires two CloudWatch alarms, one to scale up and one to scale down. In this workflow, metrics flow from the Kinesis data stream into CloudWatch, where they are evaluated by the scale up and scale down alarms. These alarms decide when to scale. When one of the alarm initiates, it sends a message to the scaling SNS